Good day, everyone. I'm Engineer Divya KK, Associate Professor and Head, Department of Civil Engineering, Vedavyasa Institute of Technology. I'm here to present a tech talk on the performance evaluation of pre-stressed concrete containment vessels. The contents include introduction, configuration and construction of pre-stressed concrete containment vessels, evaluation of failure modes of PCCV, maintenance of PCCV, and advances in PCCV. This is the general layout of the nuclear technology and the generation of electricity from the nuclear fission process. Safety of all nuclear facilities depends on the integrity of civil structures. Among them, pre-stressed concrete containment vessels is a key structure. Advantages of the PCCV are it permits greater optimization in the final selection of vessel diameter, volume, and pressure. Remains in compression during normal operating conditions, and it is aesthetically desirable. This is the containment configuration. This is a containment vessel in which the pre-stressing action is included. It is a pre-stressed concrete layout. There is a steam generator inside it, and reactor coolant pump is also there, and there is a reactor pressure vessel, and the underlying layer is of a reinforced concrete base mat, and the overall structure is constructed of pre-stressing. This is the configuration of PCCV. Post-tensioning is used on cylindrical portion and dome to balance the membrane forces due to internal pressure. Pressure loads on base slab are resisted by the soil reaction and the rigidity and strength of the reinforced slab. Thus, no post-tensioning is provided in the base mat. Solely the overall structure will be post-tension, and the basement will be of reinforced slab. This is the construction of PCCV. It consists of steel reinforcing bars, pre-stressing tendons, and concrete. Pre-stressing system includes strands, mobile tightening anchor, fixed dummy anchors. Strands are of 450 high-strength 5 mm wires with a force of 1000 tons and 590 feet length and 13 tons mass. Yield strength is of about 222.5 ksi and tensile strength is of about 240 ksi, and modulus of elasticity is about 28.9 into 10 raised to 3 ksi. 1 ksi is 6.89 Newton per mm square. And this is the construction procedure. These are the figures for strands and the fixed dummy anchor. Portable hydraulic jack is also there. This is the overall figure of the construction of PCCV. It consists of helical loop strands, orthogonal loop strands, mobile tightening anchor, and fixed dummy anchors, and also a ring girder. Vertical cylindrical wall strands are put in helical loop position and it is anchored both ends at the ring girder. Dome strands in orthogonal loop configuration with anchor at ring girder, and this loop pre-stressing system allowed cancelling of upper and lower jack galleries. And the concrete used is ordinary Portland cement concrete, coarse aggregates and fine aggregates, water and admixtures, and the water cement ratio varies from 0.38 to 0.42, and the compressive strength of concrete varies from 40 to 50 megapascal. Failure modes of PCCV. There are potential failure locations, failure modes under increasing pressure and seismic loads, cracking in wall segments, and bursting failure. So these are the potential failure locations. The locations are denoted in the figure. Underground there will be soil pressure, and these are the various locations of the potential failure. Continuities were provided with extra reinforcing steel, and at these failure locations, bending stresses are superposed over membrane stresses. Concrete cracks at these discontinuities reduces stiffness, thereby reducing the bending stresses. Hence, discontinuities are secondary type of failure. Dome shell and containment wall shell are away from the supports. Away from the supports are the primary potential failure locations. Maintenance of PCCV. Main feature of PCCV is that it uses unbonded tendons. To ensure the performance of PCCV, in-service inspection is done periodically. It is done in order to adjust the tendon force, replace tendon if required, monitor pre-stress. In-service inspection is performed at first, second and fifth year of operation up to 40 years. Visual inspection, inspection of the pre-stress system and inspection of corrosion protection medium were also performed. Advances, the modern advances in PCCVs are PCCVs with fiber reinforcement. Fiber reinforced concrete includes small fibers that are randomly distributed in the concrete. FRC fails in tension only when fibers break or are pulled out of cement matrix. Fibers in concrete resist the growth of cracks through bridging action at the cracks and enhance the post-cracking behavior of structure. These are the PCCVs with FRC. Influence of fibers on the ultimate pressure capacity of a PCCV is investigated, and it was concluded that steel and polyamide fibers were used in 1% volume and 1.5% volume respectively. Splitting cracks were observed in RC specimens. Transverse cracks were smaller and closely spaced were observed in RSFRC and RPFRC specimens than in RC specimens. Crack widths and lengths in RSFRC specimens were smaller than reinforced PFR's pre-stressed fiber reinforced concrete specimens because the bridging effect of steel fibers is significant. Now coming to the conclusions, PCCV is highly reliable structure under conditions of maximum design and accidental loads and actions from outside. It remains in compression and results in a crack-free and aesthetically desirable structure. Hoop tension failure at about mid-height away from discontinuities is the most likely mode of failure under pressure load. Pressure relief vents shall be provided to prevent bursting failures, and performance of PCCV is maintained during the service life by periodical ISI. Results of ISI showed no cracks and damage that could adversely affect the structure of containment. Ultimate pressure capacity can be greatly improved by introducing steel fibers at 1% volume of concrete, and it increases the pressure capacity by 12% with respect to conventional concrete. Thank you.